After a considerable period of silence, Tencent has finally released the Hunyuan 1.5 model. From its promotional video, we can see that this model possesses many traditional video generation model features, such as support for excellent camera movements, support for both Chinese and English adherence to physical laws, and more detailed expression performance. The biggest highlight of this model is that it is a lightweight model and can directly generate 1080p videos. What you are seeing now is the Hunyuan 1.5 page on GitHub. From this information, we can see that its parameter count is only 8.3 billion. Additionally, as we just mentioned, it can directly generate 1080p videos. Of course, 1080p here is the maximum resolution. It actually supports 480p, 720p, and 1080p simultaneously. If your VRAM is 14 GB or higher, theoretically, you can run this model directly. Currently, ComfyUI officially supports this model natively. Although we cannot find relevant information on their blog, you can directly open the official ComfyUI documentation. You can click on Video, and then inside, there is an entry called Hunyuan. Looking further, there is one called Hunyuan Video 1.5. This is the new model we are discussing. In this section, you can find detailed installation instructions and the working workflow. For installation, you just need to update your ComfyUI to the latest version. Note that during this update process, you must update not only your backend program, but also the frontend program. The other crucial step is model download. We have two ways to download the models. The first method is to download the models directly using the links provided in the documentation. For example, there are two text encoders, the Qwen2.5 VL model and the T2V model. As for the main models, two are listed, the 720p text-to-video model and the 1080p upscaling model, along with the VAE specifically for Hunyuan 1.5. After downloading, you can store them according to the provided directory structure. Aside from downloading models via these links, you can also click on the ComfyUI repository page on Hugging Face. Here you can find downloads for various related models. First, we look at the main models. Within the main models section, there are many files available for download. They are categorized by resolution. There are 480p and 720p versions. But note that there is number 1080p generation model. The 1080p resolution is achieved through an upscaling process. This is why there is an upscaling model listed here. SR, of course, means super resolution, or increasing the resolution. Models are also categorized by format. They have distilled models and traditional models. All distilled models will include the keyword distilled. The distilled and non-distilled models do not have significant differences in sampling steps. Their differences are limited to the design of the CFG classifier free guidance. This concludes the main models section. Next, note that there is also a LoRa here. This LoRa was recently uploaded by Kijai. This is a 480p light T2V text-to-video, 4-step accelerated LoRa. I haven't tested this yet, but you can try yourself. Regarding other downloads, please check them out yourself and download what you need. Furthermore, we need to focus on latent upscale. This is essentially a type of upscaling model. We must clarify the difference between this and the SR model we just mentioned. Latent upscale is only used to enlarge our latent space. However, the actual sampling process requires a main model, and that main model is the SR model. We have covered all this prerequisite knowledge mainly to make the application process easier for everyone. Next, all you need to do is download the required workflows. As you can see, there are two workflows here, one for text to video and one for image to video. After downloading, drag them into your ComfyUI. Similarly, I have also built the workflows on Running Hub. You can access this platform through Running Hub in the ComfyUI space. Running Hub is an excellent online workspace because whenever new technologies and models appear, they are adopted immediately. You can register for Running Hub using the invitation link in my video description. This will grant you 1,000 free points. Furthermore, you receive 100 bonus points every day you log into Running Hub. This allows you to try out your workflows for free. If you drag the official workflow in, it looks something like this. It is very cluttered. The key point is that it uses an advanced sampler, therefore it requires many preparation nodes. These nodes make the entire workflow seem quite complicated. To help everyone understand this workflow more clearly, I have now refactored it. I will use the simplest possible way to help you understand the relationship between the various nodes. Okay, let's first look at the text-to-video workflow. Note that I have two main sections here. One is the basic video generation, and the second is the video upscaling. Looking at the generated result, this is a 720p video. We can see that the effect is actually excellent. The clarity is sufficient, and the overall motion looks good. I think the representation of characters and colors is impeccable. Now let's look at the 1080p version. This one is even more detailed. We can zoom in quite a bit on the video. Look at the horse's eye, including the expression on the character's face. Everything is very detailed. Next, let's analyze this workflow in detail. First is the loading of the main model. Note that I am currently loading the 720p text-to-video workflow, and it is an FP16 model. If you encounter a VRAM overflow issue, you can change it to FP8. Since we are testing here, we will test the 720p version. I have enabled Sage Attention here. This will make the speed faster and the quality relatively better. The shift value can be set according to this list. For example, since I am using 720p T2V, its CFG should be set to 6, and its shift should be set to 9. The sampling steps is 50. However, the official documentation mentions that while 50 steps yields higher quality, it takes too long. So generally, 20 steps is sufficient for sampling. Note that we have a dual text encoder loaded here. We have loaded the Qwen2.5 VL model and the Qwen2V model, respectively. Be careful, you must select a type as Hunyuan Video 15 here. Don't select the wrong one. The VAE is native to Hunyuan, just select it. Then we generate a latent. This is also a specialized node. Since this is a 720p model, my resolution is 1280 by 720. Note that my duration is only 33 frames. The next crucial point is how to write the prompt. For the prompt, you can write it according to our standard video generation practices. However, I recommend using a prompt engineering node, placing it inside our QWL model to let it generate the prompt itself. You can open its GitHub page, which contains a prompt writing guide. From here, you can figure out how the prompts should be written. When I generated this video, I provided an image as a prompt and directly told it what to generate. The generated prompt will then have a preview effect here. Next, let's look at the sampler. I optimized that very complex sampler we saw earlier into a standard KS sampler. As we said, theoretically, you could use 50 steps, but here, 20 steps is sufficient. We use the CFG of 6.0, the Euler sampler, and the simple scheduler. After this, we can achieve an excellent result. The resolution of this video is 1280 by 720p. Now, we move on to the upscaling section. Note that we need to use another model during sampling, which is the SR model super resolution model we just discussed. Additionally, latent space upscaling requires an upsampling model, which is the upscaling model we mentioned. The main model's shift value here is fixed at 2.0. This remains the same for both text-to-video and image-to-video. We first upscale it. A specialized node is used here, called Hunyuan Video Latent Upscale with Model. This node was developed specifically for the Hunyuan model. Afterward, a new latent is generated. This latent must have our conditions injected into it. Therefore, we connect our positive condition and negative condition from before to this point. This generates a new positive condition, a new negative condition, and a new latent. Next is the sampling process. The original workflow had a more complex sampling process. It used a dual sampler. I optimized it as well. This setup is very similar to the high-low noise sampling technique in 1.2. The only things you need to pay attention to are the two conditions, the positive condition and the negative condition. The first sampler allows adding noise, while the second sampler prohibits adding noise. So observe this structure. It is very similar to the high-low noise sampling in WAN 2.2. First, we connect the newly corrected conditions to our first sampler. The main model and the latent are all connected here. The add noise setting must be set to enable. Since this is a distilled model, we use 1.0 here. 8 steps are sufficient for sampling. These first 4 steps of sampling are for adding noise. The subsequent 4 steps are for detailed processing. Therefore, we need to disable the noise here. The starting step count also begins from step 4. And note that the conditions used here are the original positive and negative conditions. After decoding, we get the effect you see now. You should note that the final result you see still has some differences compared to your original video. We can only say that it is about 90% similar. Okay, let's look at the image to video workflow to give everyone a feel for the distilled model. I used a distilled model for this image to video example. The main model loaded is the 720p distilled model. I also enabled Sage Attention. The shift value I set here is 7.0. This is still based on the reference list. What additional components are included in the image to video workflow? We have an input image here. We first resize it. The resolution I used here is 720 by 1280 because it is a vertical video. Once we have the reference image, we first encode it using a clip vision encoder to get an output. This visual encoder can be found in the clip vision folder and was developed by Google. The most critical node is the Hunyuan video image to video node. Here, we need to connect our positive condition, negative condition, and VAA. We also need to connect the start image, which is our reference image. Furthermore, the output of the encoded reference image is connected here. This generates new conditions and our new latent. We connect this to the sampler for sampling. We still use 20 sampling steps, as we just mentioned. Even though it is a distilled model, the steps should not be reduced. Only the CFG is reduced to 1.0 here. Everything else remains unchanged. Afterward, we get a 720p video. Look at it. The clarity is already very high. Then, we proceed to upscale it. Note that the upscaling model is exactly the same as before. However, you need to be aware that when using this node in the image to video workflow, more connections are required. Besides connecting the positive condition, negative condition, and latent, we also need to connect the VAE start image and clip vision output. Once connected, new positive conditions, negative conditions, and a new latent are generated. The subsequent sampling process is also identical to the previous one. Finally, we obtain a 1080p video. Look how high the clarity is. All the details are excellent. When discussing this workflow, we advise you to avoid running this specific section, the upscaling part, as much as possible. The sampling time here can be extremely long. However, note that the sampling for the text-to-video section is very fast. Therefore, try to skip this area. Additionally, note that the official Lite X2V repository also has 2 repositories related to Hunyuan 1.5. The first is for the distilled model and the second is for the quantized model. You can download the corresponding models and try them out. Due to time constraints, we won't go into detail about these. So, what are you waiting for? Try it out yourself now. Follow me to become someone who understands AI.